Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to this course on Circular Economy for Sustainable Buildings. Last class, we saw some of the techniques that can be used for resource conservation pertaining to landscaping and wastewater treatment and so on. We will continue with application of some other gadgets and strategies in some other aspects of resources for offices in this section. So, in this class, we will look at eco-sensitive accessories for offices, and first we will look at smart building services. Now, if you see, buildings comprise a major part of the world's energy requirement, and almost about 40% to 50% of the energy is wasted due to inefficient energy management of the total energy consumed by buildings. The factors like increasing population, rising energy prices, shrinking budgets worldwide have led to the requirement of energy efficient, sustainable and smart buildings. As of now, the various systems that are available in buildings, they constitute inefficient functions in them. Currently, various systems that are used in buildings make the building inefficient in terms of energy, and we simply cannot afford it if we have to take a leap towards sustainability. And therefore, there is a strong need to have smart buildings and also systems that assist in these smart building services. So, the smart buildings are considered to have low life cycle cost due to automation and control system, which is an additional feature that must be considered. If we look at how to make buildings smart, we can do it in multiple ways. So, here I have listed some of the ways of making the building smart. First is you can have, for life safety, you can have certain gadgets as well as certain systems which will monitor and control these. Out of this, first is the fire alarm system. Second is the fire suppression system. So, do not let the fire to spread. That can be through dry mode or wet mode. Then we can have smoke detection systems and then immediate paging and calling systems. The second system is security, enhancing the security in the building by giving access control. Not everybody can enter the building and not everyone can enter every part of the building. Second is have CCTV systems so that you can watch who is moving in which area, so that surveillance gets increased. Third is intrusion system, ensure no one is intruding and make the building intruder proof. Protect the perimeter of the building and gate automation. All of this becomes very, very important, especially in the context of office building. Say an office building which stores or has data in the form of data servers or any such thing. We cannot afford to let the data get breached, or maybe it's a building which is a research park or with startups. We cannot afford to let the research get stolen. Third is utility services, which has DG set monitoring, elevator or lift control. I have already discussed at length about this. Third is water leakage system. Fourth is wastewater management. Then we must have building management systems for chiller management of heating, ventilation, air conditioning system. Then the entire HVAC system having energy metering for its ventilation system and proper lighting control. If we look at the various smart building services, then we should have a proper elevator system which has good ladder logic. We should have lighting control system, smoke detection and control system. So, lighting control system can be with the help of sensors and dimmers primarily. We have discussed both of this in length. Have monitored indoor air quality system. Air quality system will include all the particulate matter, then CO2, nitrous and so on. Then electricity distribution system should be optimized. There should be good water management system, which means the when we look at water management, it also includes the wastewater management and water distribution and recycling of water. Then we should have a proper energy metering system so that we can monitor energy consumption and find ways of handling or conserving the energy. So, we will be able to strategize only if we monitor. Then we should have cooling and heating system, which is basically HVAC. We have talked about various ways of doing it, including having a BLDC fan and then various ways of handling it in terms of air conditioner. Then we should have a indoor environment quality control, which will look at IAQ, acoustics, lighting. All of this combined together will form indoor environment quality. And then we should have intrusion detection for safety and security. There should be surveillance, video monitoring, security access control, fire detection system and alarm system and fire control system and HVAC. All of this should be monitored and managed through a central management system. So, the building management system is the brain of the building and it will bring the various systems together as I had shown you in the last picture, and this can be operated by a few people, maybe one or two people. This integrated approach to the building will further reduce energy usage by at least 30%, and also the cost of this ownership of the building or operating expenditure will come down drastically, and this will also help in improving the business when it comes to office building. So, the intelligent building management system will enable monitoring, measuring and optimization of the building's performance throughout its life cycle, and this will also provide insights across all the critical systems in the building for intelligent actions. The innovative solutions for smart buildings will include quick response systems, automation, smart meters, smart panels and building analytics services. So, having this building management system will provide for quick response. So, if there is a fire, the response can be very quick because early detection happens. Also, spread of fire can be curbed. Then automation automatically shut the doors and the ways through which the fire could spread. Have smart meters so that you are able to monitor first the consumption, whether it is for water or electricity, and then smart panels in the building management system. And you should also have building analytic services, which means building analytic services, which means that one should be able to analyze the data which you collect and store in the cloud. So, in what all ways can building management services be integrated? So, the major ones are to have a CCTV, to have access control. So, security through access control system, which could be in the form of badges, door locks, biometric, or even the eye system. Then fire annunciation and suppression. So, basically protection from fire. Then looking at HVAC. Then monitoring lighting levels and controlling lighting levels. I have already told you how to do it, dimmers, sensors and so on. And then vertical management, vertical transportation management in a building in the form of lifts or elevators, escalators, whatever they may be. Now, if we look at what all are the systems and gadgets that can be used, we can have the building equipment monitoring system, intelligent lighting systems, flood lighting system specifically outside the building, e-card system for security, information release system, power monitoring system, lift monitoring system, IDC environment monitoring system for indoor environment quality, property management system, public address system for quick dispersal of information. All this can be done through video monitoring systems or CCTV, access control system through biometric or face recognition, automatic fire alarm system, creepage fire alarm system. Then we can have intruded alarm system, electronic patrol system, then a parking lot management system, parking guidance system. All of this can be automated in a smart building through smart building services. So, what is building automation and control system? Now, the term building automation and control systems, or BACS, BACS, it refers to a centralized system that will monitor, control, and record. So, these are the three things: monitor, control, and record the functions of the building services systems. Building facilities that are monitored and controlled by a reliable BACS will tend to maintain the building environment more efficiently, and so it will reduce the building's environmental impact and energy costs. The core functions of a building automation and control systems are: it should maintain control of the building's overall environment. It should operate systems according to occupancy and energy demand. It should monitor and correct the performance of these systems. Sound alerts are required. The facilities that can be controlled by BACS or building automation and control systems are lifts and other mechanical systems, plumbing systems, electrical systems, HVAC systems and rooftop units, control of lighting, security and surveillance, fire alarm and other emergency systems, vents and exhaust fans. So, what does it overall aim to do apart from monitoring, controlling and recording? We need to have a low carbon building. And for having a low carbon building, we should have good energy management system, smart energy integration services. We should have all the parameters falling into green building consulting codes and have LED lighting service, all of which can be managed by BACS. Also, we should have a healthy building. In order to have a healthy building, we should have healthy lighting which can be monitored and controlled. We should have a good well consulting, smart care solution. We should also have a smart building. And by smart building, we mean we should have access control management, parking management, smart building integration service, smart building digital service, good connected lighting, architectural lighting design, and then having a good lifestyle and livability through smart community, which can be supported by landscape lighting design, security through video surveillance and smart pole solution. All of this being controlled, managed, recorded and analyzed through BACS. Now, what are the components of BACS? So, the components of BACS are: first is sensors. What does sensors do? They measure the values of various things based on what sensors you have. Say it can measure temperature, humidity, lighting level, then it can measure room occupancy, based on which it can switch on the air conditioner or lighting and so on. So, it should have sensors. Second, it should have a controller. So, what does controller do? They instigates the system's response from the collected data using algorithms that apply logic and send the commands. And third is we should have output devices. So, carry out these commands from the controller, you need the output devices. And then we should have communication protocols. Communication protocols. So, the language used by the BACS components should be communicated, and accordingly the gadget should start behaving and the gadget should start functioning. You should have a dashboard or terminal interface. So, the user interface for data reporting and interaction with the BACS systems happen there. So, you should have a dashboard where all the data can be visible. So, having a good building automation solution will include having good facade lighting design so that indoor lighting is good. Then we should have an outdoor lighting control system. We should have good indoor environmental quality services, which will include good indoor air quality like temperature, humidity and things like that. We should have good acoustics, good lighting levels and good visibility to outside. Having a pleasant view. All of this will be good IEQ services through good connected lighting in the form of indoor lighting systems as well as outdoor lighting systems. Then we should have a good HVAC control, smart HVAC control and EV charging station. Also, we should have battery energy storage systems. Besides, for smart surveillance, we should have access control system and parking lot management system along with smart video surveillance systems. Also, building energy management should look at solar solar PV system, and then the data center should collect all the data, room automation and electrical system. So, it is comprehensive 24/7 job of collecting data pertaining to lighting, energy, analyze it, HVAC, fire, energy management and so on. All of this should be integrated. And then definitely we should have smart grid, because smart grid is the electrical grid of the future. What is smart grid? Smart grids are an automated delivery system for information and energy. The smart power grid will use computers to communicate with buildings and power sources, allowing information regarding power usage to flow from the home's smart meter to a transformer of the power company and back. This will help with load shedding during peak times and allows the power company to monitor energy usage, check for spikes, monitor the peak usage time and restore power quicker after a power outage. And this allows the integration of renewable energy. Then you must definitely have smart meters. So, smart meters are advanced meters which are able to collect data on consumers' electricity usage. They communicate these data to other power system participants on the local utility grid and get pricing information from distribution system operators to start household appliances. Smart meters not only measure a consumer's utility usage, but they also communicate with a smart grid to transfer information directly to the power company. The consumer knows exactly how much energy is being used. If a consumer generates renewable energy to sell back to the power company, the smart meter knows exactly how much energy is being sold. Integrating a smart home automation system with a smart meter will allow for control of energy usage, and this can definitely reduce energy waste. Now, what do you mean by smart automation? Smart automation systems require a hub or central controller, and it is a way to control all the devices within a particular space. There are many different types of automation or hubs on the market that serves various functions, including serving as security system, controlling the building electrical system and also building electrical devices, all of this through wireless technology. They can be controlled with apps on a mobile phone or personal computers. These apps can monitor the smart meters and the information they provide, as well as any device that is connected to it. These hubs can completely turn off appliances that are not in use to eliminate usage by idling. Some of these devices include televisions, computers, gaming consoles, coffee makers, lights, air conditioners, rice cookers. Even though they are not on, they are still using energy. These apps have the ability to turn the devices even when the user is not at home, and can schedule when these appliances turn on, and can even lock and unlock doors while being away. Also, we can have a human interaction phase. So, technology alone will not guarantee low consumption. So, smart buildings are impossible to achieve without smart users. Leaving a room with the TV or computer still powered on when it is not in use is a wastage of energy. So, data collected from these devices are also beneficial since human behavior and activities impact the building energy consumption and also indoor environmental conditions. We can use many apps which are actually advanced technology, and these apps can be linked to our phones or even smart thermostats, and this can allow people to adjust the temperature within the office for times when no one is there, and using occupancy sensors and not preset times will help us to reduce the effect of the human factor. These apps can also alert the end user to unexpected energy peaks and dips. They provide useful information and feedback to allow the user to make informed decisions. These apps will provide real-time information on peak energy usage so that the user can make an informed decision. While some of the automation systems are more for convenience, there are many others which can reduce energy use by closing even small things such as blinds on a sunny day to prevent heat exchange, or opening those on the same blinds on cloudy days, which will allow natural sunlight to be used instead of lighting fixtures. They have sensors and automation to determine when is the best time to open or close based on energy consumption and peak times. So, integrating a smart automation system with a smart meter will allow for control of energy usage, and this can reduce energy waste. Then the next accessory which will really have a big impact is toilet accessories. So, when we talk of this category of toilet accessories, let us first look at low flow water efficient toilets. We have already seen that there is a dual flush toilet. So, a significant way to save water in buildings is to replace existing single flush toilet with dual flush toilets. So, the current standards of dual flush toilets use 6 liters on full and 3 liters on half flush. The most common dual flush toilet is the 6 liters full flush and 3 liters half flush, although there are some other variants like 4.5 for full flush and 3 for low flush. We can also try to look at interpretable flush cisterns. So, the flushing action can be interrupted. So, we can look at interruptible flush cisterns. Here, the flushing action can be interrupted at will, and the discharge begins once the button is pressed, and the second press will interrupt it. So, using this, we can just about use the correct amount of water necessary. So, we need not even reach 3 liters every flush. We can also look at high efficiency toilets. High efficiency toilets goes beyond the standard 6 liter, and they use 4.8 to 4.5 liters per flush. We can look at waterless toilets or composting or eco sand toilets. But these are not very common for commercial buildings. Somewhere I have to introduce and tell you these, therefore I am introducing it here. We can have urine separating toilets which will separate the waste at the source and reduce the nutrient load by composting. They require very little or absolutely no water for flushing, and this actually strengthens the wastewater for treatment. Then we can also consider and look at pressure assisted toilets. So, these toilets use either water line pressure or a device in the tank to create additional force from air pressure to flush the toilet. So, in such cases, For every single use, there is a maximum of 4.1 to 4.5 liters per flush. Then we can also think of power assist toilets. These operate using a pump to force water down at a higher velocity than gravity toilets. Power assist toilets require about a 120-volt power source to operate a small fractional horsepower pump. Typical flush volumes are between 3.78 to 4.9 liters per flush, and dual flush models are also available in power assist toilet categories. Then there are other ways in which we can save water. Say here, if you see, I have given an example of here I have given an example where we can use dual flush toilet, and also toilets where we can have some button controls at easy reach, which allows us to raise and lower the temperature of the seat and use of this no seat. So, some seats offer automatic deodorizing and air freshening because there is a device placed below. So, these all can be form part of high efficiency toilet. Also, we can have gravity fed toilet and power flush toilet, which happens through the use of a small device inside. Now, if you want to segregate the liquid and solid waste, you can use urine diverting flush toilet, because of which the liquid waste and the solid waste gets separated. And I have discussed about this earlier also. And we can have gravity assist flow toilets, or we can have through power also. Then we can also have passive vacuum assist technology to deliver a very quiet, effective flush that consumes only 3 liters, and it is one of the most water conserving flush toilet in the market, where the water fills the tank and inner chamber, forcing air to the top of the chamber and down the transfer tube. So, there is a transfer tube here. So, the air is forced to the transfer tube into a trapway, entering a positive pressure on the water in the bowl. This pressurizes the trapway and creates a larger water surface area at the bottom. Then we have other examples of waterless urinals which can conserve water. So, we can have first low water urinals. So, in some of the standard systems, water is applied automatically through a continual drip feeding system or by automated flushing at a set frequency. So, regardless of whether somebody is using the urinal or not, there is a small drip that is happening, and this water consumption will vary with the system model. On an average, it requires 4 liters per flush, while water efficient urinals uses only 2.8 liters per flush. And in recent times, we have also had very smart flushing systems that use about 0.8 liters per flush, that has also been launched. We can also have sensor operated urinals. So, these urinals will detect the presence of people through movement in front of a sensor kept, or even in the door switches. Now, it can even be combined. And then we have the waterless urinals, where these are various technologies available for waterless urinals. So, sometimes there is a oil barrier technology where the urinal will operate through the use of an oil wall between the urine and the atmosphere. This will prevent the odor from escaping. While there is another technology where the barrier has been replaced with a seal. That seal is a collapsible silicone tube that closes after the fluid has passed through it, and this will prevent the gas from attempting to flow from the sanitary pipe into the room. The third system of waterless urinal uses biological blocks which will include microbial spores and surfactants which can be placed into any urinal, thus eliminating water use. Therefore, by breaking down the urine into components, the buildup of sludge and crystals which causes blockages are prevented. The potential water savings from waterless urinals compared to a 2.8 liters per flush urinal is almost 100%. And then we can also have faucets or taps. So, when we use faucets and we want to conserve water, we can look at aerators. So, aerators, modern taps often have aerators to help save water and reduce splashes. Without an aerator, water usually flows out of the tap as one big stream. But an aerator will spread the water flow into many small droplets. Conventional taps or faucet aerators don't compensate for changes in inlet pressure. So, greater the water pressure, the more water you use. Now we have new technology which compensates for pressure and provides the same flow irrespective of the pressure. And then next we have flow fixtures. So what are flow fixtures? Flow fixtures will control, deliver a precise volume of water in the taps or faucets, even in shower heads and hose outlets. Normally, it will be 5.6 to 8.3 liters per minute, irrespective of varying line pressure. Flow controls will work differently than the tap aerators because aerators will add air to the water stream to make the flow feel stronger, but flow controls on the other hand work by producing dozens of parallel streams of water. Third is the sensor taps. Now, these are automatic shut-off taps such as push button or level operated taps that shut off automatically after a set time in order to reduce the potential for taps to be left running for too long time or not turned off. And then these sensor taps with a flow rate of 2 liters per minute can also be installed. These taps will cut off water supply when the hand is removed from under the tap or in front of the sensor. Or sometimes it can also be a preset timing, say 30 to 60 seconds, whichever is earlier, and it will stop. So, thermostatically controlled electronic dual purpose mixing or diverting valves are used within the industrial or commercial application models, such as when used in corporate offices or hotels to automatically provide the water as required. So, this is the fourth type, which is thermostatically controlled dual purpose mixing or diverting valves. So, here we say that we can use accessories for urinals, which could be waterless urinal, low water use urinal or sensor operated urinals. Waterless urinals will use a oil barrier technology, seal with silicone tubes or biological blocks. We have seen each of this in great detail in the first few classes. Low water use urinals could use a standard system or a smart flush system, and sensor based urinals can use a movement sensor or electronic delay. All of this will add together for saving a lot of water. So, if we look at toilet accessories and cisterns, we can have the dual flush cisterns, which is two concentric buttons. Pressing the circular button will discharge 3 liters only. Pressing both the buttons will discharge 6 liters, and this can cause a saving of 4 to 7 liters per flush. Then we can look at interruptible flush cisterns, where the flushing action can be interrupted at will, and so you can save any amount of water you want because you will use only water that is needed and stop pressing it once you think the flushing is over. Then we can have urinals which can be sensor operated, or we can have waterless urinals as we have discussed in the previous class. Then here are some of the details of the waterless urinals which we have already seen, with sealant or without sealants, and then we can have the flat rubber tube and silicone membrane by Adicon. Then we can have the LPD membrane also, and then we can also have the biological blocks. So, these are the three types. One is with the oil sealant, second is with the flat rubber tube or membrane type, and third is the biological blocks. Now, let us see the benefits of using toilet accessories and how much water can be saved. So, if we look at the European water closet, conventionally it requires 6 liters per full flush, and then if we use a 1-star high efficiency model, it uses only 4.8 liters per full flush, and if we use 3-star ultra high efficiency system, it uses only 4 liters per flush. So, the 1-star gives us 20% savings and the 3 stars gives us 33% savings of water. If we look at urinals, the conventional urinal uses 4 liters per flush, the 1-star uses 3.8 liters per flush, and the 3-star uses 1 liter per flush, and this creates 5% savings when we use 1-star high efficiency contraption, and the 3-star WP high ultra efficiency gadget gives us 75% of savings. Also, when we look at shower heads, the conventional one uses 10 liters per minute, and if we use 1-star, it uses 9.5 liters per minute, and 3 stars uses 5.7 liters per minute. Therefore, the 1-star WEP 1 high efficiency gives us 5% of savings in water, whereas the 3 stars WEP 1 high ultra efficiency will give us 43% liters per minute savings. If we use lavatory and faucet sinks in a conventional way, it uses 8 liters per minute of water, whereas a 1-star does not give any considerable difference, whereas the 3 stars gives us 5 liters per minute of usage, causing 38% water reductions. Also, the various fixtures where we can look at water savings is shower heads, kitchen faucets, lavatory faucets, metering faucets for wash fountains, water closets, urinals, commercial pre-rinse spray walls. So, all of these can be made water efficient. So, today we saw comprehensively two major things. One is building management system in office buildings, and we also saw water management or use of proper accessories in toilets in offices, and sometimes mildly dwelling here and here in other typology buildings also. With this, we will stop today's class and we will continue our next class with another topic. Thank you.